Our plan will be, I'm going to just recap a little bit about our chapter, but try and reflect upon some of the themes that you've already heard today. And then I'm going to sit down and ask my co-editor of this chapter, Andy, to lead our panel through a discussion of some of the issues that are raised. So I'm going to let Andy introduce the panel, and then I'll give a brief recap.
Great. So thank you. I'm Andy Auerbach from UCSF, co-edited this chapter with Stephen. Mike Matheny, who you know from earlier today, he's wearing a different hat now. He's now presenting, because this is a chapter on how to clinically deploy AI. He's helping us think through those issues in his role running his center at Vanderbilt. To his left, Sarah Murray leads the Advanced Analytics and Innovation Group at our EPIC in-house shop at UCSF Health, and oversees the deployment of all the AI tools, machine learning tools in UCSF Health. So useful perspective there. And Natalie Pagler, who many of you know, is Chief Medical Information Officer for Stanford Children's Hospital, and has a similar role there for the Stanford Health System, particularly for children. And we'll get to ask them more questions after this.
Thank you. Well, for those of you who were here at the beginning of the meeting, can you hear me? Is my mic on? I'm from Seattle, so we've heard about Boston, we heard about Washington, we heard about Chicago. I happen to be from the city that has the only team in baseball that has never been to the playoffs, much less the World Series. So much of what there's obviously great overlap in these chapters, and that was an issue in the development of this book about what belongs where. And so I think some of the repetition is probably helpful. I can advance these, can I? So I think with a typo in there, we just sort of recapitulated what we view as our sort of utopian view of what AI could be. And I think we've heard some of the caveats as well, and I will join Jim Fackler perhaps as being somewhat of the curmudgeon of the book, but really from the standpoint of being optimistic about what this technology has to offer, but also cautious in how we implement it. Now, I'm from Seattle, as I just said, so many of you have not probably been as immersed in the situation with the Boeing 737 MAX, which is always on our front page, and also the self-driving cars on the right. I would commend to you actually reading about this incident. I won't go into detail, but to make a couple points, because I think it is really an object lesson in how we probably shouldn't integrate AI into human systems. But I'll come back to that in a minute about why that particularly pertains here. But for those who are familiar with it, there are several errors which have been alluded to on this stage that I think came to light, including some commercial pressures, and Sanu talked about the commercial pressures that go not only actually from the manufacturers, but from the customers, the airlines. There were assumptions built into the model about how the airplane would respond, that this would be an unlikely event, that there was a single point of failure. But there were also some assumptions about who would be using the model. It turned out, rather than experienced pilots, there are a lot of inexperienced pilots flying planes now who really didn't know what to do in that situation. And the one thing I'm going to come back to is there was a real lack of feedback systems built in. I wanted to go forward here. So again, we've heard about we're going to be living in a wired world. Right now, and our chapter really focuses more on the now than the future, although there are implications for the future, is that AI, healthcare-related AI, is going to be ubiquitous, not only in healthcare institutions, but maybe more so in other locations like pharmacies, markets, outside of folks who do population health management. We've heard from Ronak Trivedi about caregiving. And right now, the big areas where we're seeing health AI is obviously in image processing, which we've heard about, and in prediction. And the question is then how to integrate that into the clinical sphere. So again, Nigam and his group really, I think, did a nice job of talking about the development of prediction models. I edit a journal. I would say we get 5 to 10 papers a week describing a new prediction model. There are literally thousands of these in the literature, and a very, very small proportion of them have actually been validated outside of their clinical system in another data system, and almost none in other data systems, and even less than that actually in clinical action. So the issue here is not being able to build the models. The issue now is sort of being able to assess and implement the models. The holy grail here is to integrate these AI applications into some sort of clinical decision support. Clinical decision support nowadays is still fairly crude. It's usually rule-based, Boolean kind of logic, very little AI actually in place, although we've heard about sepsis models and some of the other models, which may be some of the exceptions. And I'll just say, what we're talking about in our chapter really is the last mile. It's taking those models and putting them into practice. I'm going to quote Paul Tong, where he said it's all about workflow. It's very hard to take these predictive models. I'll just use one of my own personal examples where we developed an algorithm now almost 10 years ago to predict death and hospitalization in VA patients. We derived it from 6 million patients. We validated it. We implemented it. We put it into the clinics. The docs all say they like it. We've actually published, I'm not making this up. And yet only about 15% of the relevant docs over a decade are actually looking at the data. So that just simply making it available without integrating it into workflow in a meaningful way that clinicians can use and see as valuable is simply, you've got to do that. In today's world, how does this get adopted? I mean, on one hand, you could see another clinician could come to you and say, we have a problem, we need to solve it. I've heard there's some software. It could be an administrator coming in to say, we have to fix our CLABSI problem. We need to get software, or our sepsis problem. Even worse, it could be a representative from a company coming to sell you a product. But this happens in real world, in real life. And where our chapter really spends a lot of time about is sort of thinking about what is the framework that an institution, a healthcare system, might use both to think about implementing and to implement an AI application. And this will look to you like a standard PDSA model, which it is. It's been sort of configured for AI, but it really, and this gets back to Jim Fackler, who pointed out that if we don't use a learning health system model for this, that we're doomed to failure. I think he's correct about that. And it also gets to what Peter Emby said earlier about algorithm of vigilance, which just means we really have to pay attention, and the question is who should do that, and I'll mention that in just a second. We heard from Nigam all the characteristics that the model has to have, so it's really important, first off, that we identify the target well. And I think Mildred Cho really talked about the need to have the target highly specified. What is the problem we're trying to solve? What is it we're trying to predict, and why? And then to go to the literature and look up and say, are there models out there that meet our criteria? And you've heard a lot about interpretability and data sources. and maintenance. I won't go through those again. We also heard from NIGM's group about sort of the baseline requirements that we might have in our system. Do we have the technology? Are they going to be flexible? Can we apply this to more than one problem, or is this a single problem? How much do we standardize? How much do we customize? Do we get this from our EHR vendor? Do we buy it as a standalone? There are a lot of kinds of hard questions that systems will have to use. And then also, we've heard about the human and user-centered design considerations. We've heard a lot about safety, something about security and privacy. And we will hear in the next talk a lot about the regulatory issues that come to bear. And those are important as well. I'm going to Dr. McGinnis, who welcomed us here, I think has been a champion at the National Academy for Learning Health Systems. I've sort of put my own sort of spin on what I sort of see as a learning health system, which I think is just a way of capsulizing the fact that we have to learn as institutions and as communities from our experience with these. And as Jim said, if we don't, it's a problem. I think I commend that book to you from the National Academy, because it really hits all the points that we've talked about today, including of being patient-centered, involving communities, and being transparent. There's also, our chapter talks a lot about governance, and this gets back to this algorithm of vigilance issue about, we heard a question from the audience, who's responsible here? Is it the government? Is it industry? I don't know the question to that, but my view is if institutions are developing and adopting this technology, then they automatically bear responsibility for participating in that. They can't abdicate that because there isn't an adequate system in place right now. And I think that's one of the themes of our chapter about how that gets done. And one of the things, this gets back to the sort of 737 MAX issue that sort of the Indonesian government published a couple weeks ago, a 180-page report from their perspective about what happened. But one of the interesting features of it is that the airplane that crashed in Indonesia had done in the previous flight, that system had activated 20 times. Had to be corrected by the pilot. And the pilot forgot to tell anybody about that, or decided not to. And one of the things you think about is in our healthcare system, we can build, one of the themes of our chapters, this all can be built into the system, right? Why do we have to depend upon a pilot to tell the next pilot, oh, by the way, this plane doesn't fly right? When in fact, that should be integral to the systems. And we try to make a strong case for a lot of this vigilance just needs to be programmed into the systems. And if the systems don't have the ability, if we've got to go in separately and pull data and analyze it rather than having those data presented to us, then that's probably a problem. It is a problem. So I'm not going to let you go on break quite yet. I'm going to stop and hand this over to my colleague, Dr. Auerbach, who's going to lead the panel here.
Great. I'll give you a minute to kind of soak that in. So Natalie, you've kind of come maybe 500 yards away from your day job.
Yes.
So you're going to go back there after this, and people to come to you with an AI tool. What is the first thing that comes to your mind when you're thinking about these tools? What governance? How do you move these into clinical care at Stanford Children's Hospital?
Yeah. So great and complex question. And I would start with saying, one, I think we are very early on in employing AI in the clinical setting. I think there's probably going to be a lot more opportunity, and we'll see first a lot in the back end setting, but I think where we're excited is the clinical setting. And I'm always, my first thought if somebody comes to me with an AI tool that's ready to go is fear. Because there are, for all the reasons that we talked about, a lot of complexities about whether or not it's going to be a useful tool. What comes more to mind in how we approach AI in the clinical setting at Stanford Children's, at least, is really thinking about a partnership between our clinical informaticists and our data science colleagues at the Stanford side. So in addition to my other roles, I'm the director of the Clinical Informatics Fellowship across Stanford Medicine. So we've got a great fellowship that goes through the School of Medicine, the Adult Hospital, and the Children's Hospital, where we have physicians who have finished their clinical training and then come for 2 years of applied clinical informatics training. And it is really, we talked in the last panel about the importance of these multidisciplinary collaborative teams, and I think the applied clinical informaticists are absolutely critical because they are helping to close that loop for a learning health system. They are knowing the workflows and where the data is coming from and helping give context to the data that's being used in developing algorithms. And then 2, they are the people who understand the information systems and know the concepts of clinical decision support and guidance and how you change the systems to affect behavior, skills, and knowledge in the clinical setting. And so that is how we are approaching it at Stanford Children's, and we've got a couple great examples of projects we've been doing where I think we're starting to show the potential, but I think it's really important to think about that entire loop and make sure that that we understand the context of the data, where it's coming from, what the assumptions are, and then think about how to meaningfully input models back into the systems.
Great. Mike, you have the interesting role of being able to both develop the tools and then try to get your health system to adopt them. What do they tell you when you bring things over to them from your lab?
Yeah, so it's been a really interesting experience trying to translate what is a research endeavor into an operational endeavor. And I can honestly say that, I really did have a hammer and looked for the nail in my prior experience, and it's a mistake. It's one that I've learned better from. And so in the recent, so there's sort of 3 machine learning based prototypes that are sort of working their way through Vanderbilt now. One of the 3 we're involved in, and it's really been an exercise in defining who's the health system executive leadership sponsor, who's the on-the-ground clinical champion, who's the clinical informatician, who's the data science, where's the health IT investment and sustainment, and sort of what's the governance and execution process. And we've been sort of trying to fly the plane while we've been building those pieces. And so I'm hoping that as that matures, we see that sort of level out in flight and be stable. But it's been sort of an iterative process where really the modeling piece ends up being just one small piece in the middle, but a significant one. I think the other point I would make there is when you translate a research grade tool into an operations tool, some of the pieces you need for publication have no relevance to what you need in an operational implementation. And so learning how to talk with your operational partners and show the characteristics that are important to them have been a learning curve as well for those of us that are trying to straddle both sides.
Great, thanks. So Sarah, you and I talked about this on the way down. We carpooled. We have the opportunity to both look at algorithms that come to us from researchers, but also from vendors. And how do you? Are there different issues that come up as part of what Natalie or Mike talked about, or how do you approach that in your mind?
Yeah. So, I think so. As you described, I kind of bucket our development and deployment into those 2 categories. So, how do we evaluate our vendor provided models for trustworthiness, and then how do we evaluate our locally developed models? I think the latter is actually an easier question. So when we think about deployment of internally developed models, Andy has led a very interesting infrastructure that is, I think, worth discussing as well. Having the Learning Health System Oversight Committee evaluate these models in a randomized fashion, and having a true kind of data safety monitoring board to evaluate the deployment. I think our team has spent a lot of time evaluating some of the EHR vendor provided models, and a lot of issues have come up around trustworthiness in doing so. And I was actually reflecting on that as you were speaking about responsibility, because for us, we are a well-positioned academic medical center that has a data science team that is partially committed to evaluating some of these models for trustworthiness. But as these vendors aren't just serving academic medical centers, they're also serving small community hospitals. When these models are provided to those small community hospitals who can flick a switch to turn on prediction of clinic no-show, are they responsible for the the ethical ramifications and the evaluation of that, because many places aren't positioned to really do that full evaluation for trustworthiness. And so I'll give an example, like we were looking at a vendor-provided model for predicting no-show. And as we kind of unpacked this model, we learned that there are a lot of features in the model that could potentially lead to discriminatory action if used for overbooking clinic slots. So race, ethnicity, BMI, everything you might imagine could be associated with historical clinic no-show was in this model. And so our team actually rebuilt the model when we saw this, and we excluded all these kind of explicitly discriminatory features. But after that, are we good? And I think the answer, if you really think through the guidelines, the European guidelines for trustworthiness, and what we should be evaluating in our deployment of models, if you have a model that's basing prediction of future no-show behavior on prior behavior, there are socioeconomic determinants of health that are already influencing that, and so you may end up overbooking your marginalized patient populations and giving them a suboptimal experience if they actually show up for clinic. And so I think that there are so many layers of nuances to explicit bias and implicit bias and how we think about what we do with these models in healthcare. It's really critical that early in the development, I think people are thinking about the utility and what these models are used for, because as much as any of this other, as much as the validity and the data behind it all matters, how people act on them is equally important and probably the most important thing.
That was great. I want to unpack this idea of trustworthiness a little bit more, because it came up in the earlier session. I think it's been a theme earlier in the day. I wasn't here earlier. So what makes it an algorithm trustworthy? Is it AUC? Is it statistical properties? Is it something else? Again, there's a scientific trustworthiness, but we're talking now about clinical trustworthiness, and both kind of for providers who might use it, or a health system, for lack of a more subtle way of saying, who might actually want to buy it and pay for it. How do you think about trustworthiness? We'll go ahead and go from Natalie over again.
So one of the ways we think about it is related to a paper that Nigam and Steve Bagley just published in JAMA around thinking about the value of an intervention. And I think it goes back to what you said, right? How you're going to use this and what you're going to do with the information is one of the most important pieces. And so it's not necessarily just the AUC, it's also thinking about what is the intervention and what is the expected utility of the intervention. So if you have a false positive, what is that going to be? What's the cost of that? If you have a false negative, what's the cost of that? And what's the value of you're going to get from it working as designed? So example, right? So we all talk about either sepsis or early warning systems for decompensation. And you have to think about, what are you going to do with this information? So one thing you may do with this information is send a rapid response team out to the patient to check them out. And that sounds pretty benign, but then you start thinking, okay, a rapid response team is an ICU physician, a respiratory therapist, and a ICU nurse. So now you've got 3 highly trained people who are expensive and who are leaving the ICU with an ICU full of people that are sick and that do need their care. And so when you start thinking, okay, yes, the value of finding somebody who is decompensating early, there's clearly value, but when you start combining that with the cost of sending out your team multiple times a day for people who don't need their care, you really want to look at what is the balance of how often you can handle the false negatives versus false positives to truly get an overall value to the system. And so for me, it's thinking about that intervention, thinking about how reliable is that model, and how am I going to tweak my cutoff points for that model in terms of what intervention I'm employing.
Great, thank you.
Yeah, and so I tend to think about this in terms of a differential spectrum of what level of trust is reasonable to deploy in certain environments. Like you might have a different level of trust and transparency, which sort of interact with each other on a certain axis for like a back office business scheduling, even though even as you mentioned, that has significant potential bias impacts. Whereas you might have certain data requirements, data transparency and trust in the data. You might have certain requirements for trust in the algorithmic pieces, or maybe you don't have to, depending on what you need. And maybe it's okay for it to be a black box. And then you might have certain thresholds of performance that you need reported, not only AUC and discrimination, but calibration, so that you can assess the performance at certain portions of the risk curve. And so I think what we're converging on is sort of a sense of a whole package of reportable, transparent measures that need to always travel with these things in order to encourage trust in their use.
Great. Thanks.
Yeah, so most of you are probably familiar with the European guidelines that were published for the 7 ideals of trustworthy AI, and I think they're really applicable in healthcare. Some of them are more challenging than others, so human agency and oversight, those are things that we think about a lot. Transparency, I think, is a really difficult thing, because as we move towards more sophisticated modeling, that may be impossible in some cases. But then, I spend a lot of time thinking about, principles like making sure we're not discriminating against certain patient populations, and making sure that, I think model robustness in and of itself is part of trustworthiness. And as you mentioned, like if we're given a model by a EHR vendor that predicts something within R-squared of 0.09, like, is that a model that's even ethical to implement? Because we're going to be spending tons of healthcare resources trying to act on a model that maybe isn't much better than chance. And so I think, I refer back to that document now that it exists when I'm thinking through this, but I think it's kind of broad. All of these things are broadly important.
Great. Nick, I also want to speak to the room for a moment. I'm going to ask one more question to the panel, but I want to leave time for the last 10 minutes for you guys to ask questions as well. So feel free to kind of gather your questions and go to the nearest mic or wherever that magic cube went. So you can rely on the wisdom of our team up here. So AI tools don't exist in a vacuum. They're not like, there are competing technologies in there. One theme, a separate part of my life, we're leading collaboratives that are thinking about adding APIs to health systems. And there's a big decision about whether you build, buy, or stick with what Epic or Cerner, or whoever it is, gave you. How do you decide on an AI-driven tool as opposed to something that maybe a little easier to build, a little less whiz-bang maybe, but how do you make those decisions?
Am I first again? Man,
No,
I sat in the
I'll
wrong
go in the
seat.
other direction. Sorry, I was looking at you, but thank you. So Sarah, why don't you go ahead?
Not AI?
Yeah.
So the answer should always be not AI if you can get away with it, because if you can do something that's rule-based, or you can use simple, like basic statistics that people understand, like regression, where there's coefficients, I think that's the way to do things. I think the added benefit is in more complex modeling, where we really can't do good prediction with the basic statistical techniques. So I like things simple, and I think that especially for deployment in a health system, simple is generally better.
I didn't pay her to say that. Go ahead.
Sure. So I completely agree with you. I would say that, I don't think, even if you were trying to take an off-the-shelf tool and try to implement it, I just don't think that you can do that without potentially recalibrating it or readjusting it to your local population. And so I think that that's a couple things. One, there's sort of an evolving best practice around building in your real-time data streams, deploying these systems, watching them in the background before you actually turn them loose in live environments, so that you make sure that it's performing the way that you expect it to. And then also there's the framework of data changes over time. So if your algorithm is predicting what was in the past, eventually it's going to drift away. Inevitably, it's going to drift away from where you want it to be. And so you have to have systems in place to be able to correct that and iteratively keep it up to date.
Great.
Can I add one thing to that? So I think it just reminds me that with some of these vendor-provided models, the idea is you just turn it on and it doesn't even retrain on your data. And so when you see that, I would just be extremely cautious, because something that might be developed on a population in the Midwest isn't going to be applicable in San Francisco. So
Absolutely. Yeah, and I just reiterating a lot of what you guys have said, but I think you would have to find the right tool for the right case. And so if we have something simple and less costly that's going to solve the particular problem that we have, then yes, use that, right? It's when we have a high value or high cost problem that we're trying to solve and no other tools, then it's worth all of the extra work. I mean, there's an intense amount of work, as you can tell, to both develop and test these models right now. And so it has to be worth that amount of work and upkeep in order to do that, to solve your problem.
Great. And I'm not lying to the group. So, but I don't want to end on a pessimistic note either. Where are you most hopeful? I mean, where are you most excited? What are the projects you're working on right now that you're most excited about? I think there's a real hope here, but I want to make sure that we end with that before we open it up to the room.
So I'm lucky to be at Stanford and the incredible group that's doing AI and imaging, and so I think there's a lot of really exciting potential there. And Kurt Langlock's in the group. We right now have a bone age algorithm that was developed by Safwan Halabi, Matt Lundgren, that we are doing a clinical trial with in 8 children's hospitals across the country, randomized clinical trial using this bone age, not the most exciting intervention, but I think it illustrates a lot of points to really see how using AI input with a radiologist, as opposed to the radiologist making their judgment alone, seeing if we can get better interventions that way. And I really think, it is an early science in the clinical setting, and there's a lot of great work that's been done in the computer science, big data science side, but thinking about how do we now translate some of that into clinical trials is the next big step. So very excited about the potential there.
I would just quickly add, I'm actually very optimistic about the use of some of the tools. We've seen noticeable improvements in performance and sustainable performance, as well as the ability to sort of remain calibrated across different spectrums of your population with the use of some of these newer technologies. You just can't fire and forget. That would be my only caution.
Yes.
I'm very optimistic about AI for use in actually some operational purposes. So we have major problems in our hospital with throughput, capacity management, patient access, and a lot of these are challenges that I think predictive analytics could really help us with resource allocation. So it's a different question than trying to predict, clinical deterioration, but in a lot of ways the data is maybe more reliable than some of the biases that we see when we try to do predictive analytics in healthcare. So I'm pretty excited about that.
Great. Well, thank you. As people come to the mic, I want to thank the panel before we I sent them 17 questions, asked exactly 0 of them during this last. So thank you for rolling with the questions. Any questions from the group? Oh, the Magic Cube.
Hi.
Go ahead.
Hi, thank you very much for this panel. It's wonderful. My name is Elizabeth Ozer. I'm a professor at UCSF in the Department of Pediatrics. So I have my colleagues up there. Thank you. So I wanted to follow up a couple things. One on this idea of trust. And the colleague in the last panel had talked about there was some mistrust between the computer scientists and the clinicians. And I know that sort of something like a clinical informatics program is probably very helpful with that. I'm a psychologist who's collaborating with computer scientists on actually doing game-based learning that extends the reach of the clinician for behavior change. And it's striking to me, we've now worked for 7 years, but one of the things I tell people is how much trust there is now in terms of understanding and learning and how much time that takes. So that was a trust that we didn't quite talk about in this, but I just wanted to raise that in terms of these collaborative teams and actually being more effective as teams. And linked to that, I wonder again about, I guess Dr. Matheny had mentioned how you kind of link between what's going on research-wise and then how you do how you integrate that clinically. And I'm more interested in hearing more maybe from some other panelists as well on that process, because as a researcher in a healthcare system who's developing something, what does it take to be able to translate that? And again, back to trust. We have lots of faculty who are developing, mine extends the reach of the clinician. It's not necessarily, it's somewhat different than some of the examples that you've used. So just, I'm interested in ideas about those processes.
Maybe one of the panelists could take on that last question about translating from creating enough trust so that the translation from research into practice is easier. I'm not going to look at Natalie because I kept picking on her. So Mike, because you're closest to that space in your health system.
Sure. So I really think it almost changes your frame from one of sort of investigator-initiated research to one of partnered research, almost like the Query program in the VA, or where you become an expert at a system and a methodology and a framework, and you approach the health system leadership or you approach the clinical system with, hey, I'm an expert in these systems, but what's your problem? And let's work together to elucidate your problem space. And if my skill set or the team of data scientists and clinical informaticians can fix that problem or can help you with that, that would be great. Yeah, I think it's becoming harder and harder to sort of develop a whiz-bang algorithm and then sort of shop that around for implementation evaluation. You have to be open to a wider array of technologies so that you're not trying to potentially complicate the clinical environment.
Great.
It's maybe a politic way to say it.
Yeah, I was along similar lines. I think one of the challenges with bringing research to the clinical environment is there's often a disconnect between the health system's institutional priorities and a researcher's. And so one of the things that I've tried to do is, when I, talk to folks at our Institute for Computational Health Sciences or whatnot, share the health system problems, because there are really good brains in that room, obviously, who could be helping us with some of those problems, as opposed to some of the, not more esoteric, but things that people are working on that may not be what health system has resources to devote energy into deployment for. Andy's, I mentioned the Learning Health System Oversight Committee, but you may want to speak to it, actually.
Well, so I think, and just to come back to the AI, AI is driven often by the data that are available, and often that doesn't answer the questions most important to the health system at the time. So you have to square that up front when you're doing your project. We have this mantra in our Learning Health System Committee that every research idea is a great idea. It has made our great idea for UCSF right now. Mm-hmm. So you have to think about how to square that circle early, and often that comes down to translating into a clinically important problem, something that's feasible, cost-effective, and all those things. And it doesn't mean you don't do research, it just means you have to think about what your market for your research is, whether it's a larger use case or one that's specific for your health system, which is dealing with very specific issues that you know better, or maybe don't know, but they don't better than you do. But a great question, and again, it's a kind of part of the arc of technology translation generally, and again, specific to AI, because it is a much more unknown set of technologies, a lot more hope, a lot more black box, and often dependent on data that people are a little reluctant to let go of or can't get access to.
But he's built a framework for taking in those types of projects. So there is, like at UCSF, we had this Learning Health System Oversight crowdsourcing where people kind of put in the biggest problems that they want to work on, and then people voted on it within the health system and beyond, and then we devoted EPIC resources and data resources to helping people get those projects implemented. So I think that there needs to be more work like that where we try to really bring together the health system and research community.
Thank you. We have time for maybe one or two more short questions.
I'm a primary
care
doctor.
Magic Cube,
Yeah,
excellent.
I'm a primary care doctor at UCSF, internist at China Basin, and I really welcome the AI to primary care. And as you know, there are many primary care startups in the Bay Area that have already started using chatbots for triage of the patient emails that are coming to the clinics. And obviously, the deployment in an academic center is going to be very thoughtful. It's going to go through committees, but that's not happening at startups. And it's just they're turning on the button, and patients are going live, asking questions. Yeah. How do you see the deployment of AI in the community without hindering the oncoming of AI? Do we need a clinical trial? And obviously, if the triage is wrong and someone has, an MI versus just, costochondritis, there can be really serious repercussions.
So you're looking at me, but I'm going to turf it to the committee, or my group here. I will say also the next session is going to get at that a lot. I think the regulation is really super important. What do you guys think about the guys that come out of Ford Barrel Roasters on Valencia with their chatbot app? How do you approach those folks?
Well, I mean, I think as a healthcare system, if we're partnering with them, there's a whole different level of scrutiny that we need to have. So it's one thing for these out in the community without any healthcare involvement or academic involvement, and I do think the next panel is going to be very important to talk about, because I think we do need to have increasing conversations about what the warnings are for customers who are using that without any guidance. I think if we are taking those and making them part of our healthcare system, they have to go through the same level of scrutiny that we are talking about for any of our other algorithms. And again, there are costs associated with mistakes. And so really thinking about what are the benefits versus what are the costs, what is that intervention going to be, what is the patient going to hear, and what are the warnings around that going to be if we're going to use that within a healthcare system.
I was just going to make one comment, a couple quick comments. One is, how many health apps are there in the Apple Store?
A ton.
A guess? Well, that's between the two, between NIGM and, so it's 330,000 apps are in the Apple Store. How many have been evaluated? Maybe a dozen. And if you look at the literature on the evaluations of most of these, they're negative. So, you know, I think it is use at your own risk at this point in time. And the other piece is that it may, you know, not only, the risk is not only they miss the MI, but if actually you look at most of these, what they do is they tell everybody to come in. That most of them actually have been set with their specificity, their sensitivity so high that they're really, you know, so it's impossible to know what's going on. So, I mean, it sounds like a, you know, egghead academic, but I think if we go back to being patient-centered, what would the patient say in that situation if they knew what they were dealing with?
Great. I think we have just one more short question before we finish, if that's okay. I've just been watching that white cube go around. So
Thank you, Sally Oken from Patients Like Me. You know, along that same theme and in the spirit of a learning health system, I would challenge you that those of you who are doing this testing now, you have an opportunity, I think, to crowdsource about who are trusted data partners, who are you identifying in these vendors that you would say, I think this is a great source of algorithm development, and I'd like to you know, illuminate them in some way, because you know there are people in primary care and those of us who are working in other kinds of environments who don't have the resources you have to test these out. So I think let's put the learning health system cross-institution, cross-community, so that we can benefit from the work that you guys are doing, which is fascinating and really exciting.
I think part of the challenge is, you know, again, I'll keep saying that I think we're very early on in using this in the clinical setting, and I think some of what you're hearing up here is that everything needs to be fine-tuned to the exact instance that you're using it in, and so we are very early on in trying to figure out what are the generalizable lessons to use. So I mean, you can talk about data sources, but again, it depends on what are you trying to apply that data source. You can talk about the specific models that we're using, but most of these models we're only validating in a very specific instance. So I think we're a ways from getting to like generalizable knowledge that you can spread to the broader community.
So thank you. Go ahead.
I was just going to say, following up on that, what I have learned has almost been the opposite of what you're saying, in that our trusted partners have baked in algorithms that aren't good for us, or you know, not good for our patient population. So I think, and that's been you know, we've seen that published a couple. I think we need transparency. Yeah, no, I agree with that. Yeah. I agree with that. But I think we have yet to identify, like, oh, this vendor gives us awesome models, and we can just deploy them off the shelf.
And I just want to add one last. So I think your point is really well taken in that, you know, if we develop these best practices around how these things are supposed to be done, and you have a center or a medical community that doesn't have the resources to get them done, we're at risk for a whole nother axis of health inequity, whereas these tools get used and are and help patient care, but aren't available in all environments. That, you know, it could be a big challenge.
Absolutely.
Please join me in thanking my panel.